Let's look at divisibility rules for 2, 3, 4, 5, and 10. A number is divisible by 2 if the ones digit is even. We can ignore the thousands, hundreds, and tens place because thousands, each thousand can be 2 groups of 500, each hundred can be 2 groups of 50, each 10 can be 2 groups of 5, so we only consider the singles, the ones, and if we can break the ones into 2 equal groups, then the whole number is divisible by 2. Try these examples, pause your video, and then check back for the answers. Welcome back. 1,356 is divisible by 2 because the ones place 6 is divisible by 2. It's an even number. We ignore the thousands, the hundreds, the tens, and our ones are 2 groups of 3. If we look at 1,225, the ones place is 5. It's not even, so the whole number is not divisible by 2. We ignore the thousands, hundreds, tens, and when we look at our 5 ones, we have 2 groups of 2 with 1 left over because 5 is odd. 160 is divisible by 2 because the ones place is 0. We ignore the hundreds and the tens. There are no ones to break into groups, so we have it divisible by 2. A number is divisible by 3 if the sum of the digits is divisible by 3. This one's a little bit more complicated because we have to consider every place. The thousands will each contribute 1. What does this mean? Well, I can take 1,000 divided by 3 and get 333 remainder 1. That means that my 1,000 can be broken into 3 equal groups, each group containing 333 units, and I'll have 1 extra. Each 100 can be broken into 3 equal groups of 33, giving us 1 left over. Each 10 can be broken into 3 equal groups of 3 with 1 left over. Then I have all my singles. So I know that each place value comes close to having equal groups of 3, but every 1,000 will contribute 1 left over. If I have 2,000s, I'll have 2 left over. If I have 500s, I'll have 5 left over. So in this case, I take all of my leftovers, and if I can break my leftovers into 3 equal groups, the whole number is divisible by 3. In the case of what I have on the screen, there's 1, 2, 3, 4, 5 leftovers. 5's not divisible by 3, so this representation, this number, is not divisible by 3. Let's look at some examples. Try these and check back in. Welcome back. 1,356, we have to take 1 plus 3 plus 5 plus 6, which gives us 15. That's 1 from the thousands, 1 from each of the hundreds to give us 3, 1 from each of the tens to give us 5, and then all of the singles with 6 for a total of 15 units we need to distribute across 3 groups. 15 divided by 3 is 5, 3 equal groups of 5, so the entire number is divisible by 3. 1,225, I take 1 plus 2 plus 2 plus 5 for 10. 10 is not divisible by 3. My 10 leftover pieces, I can make 3 groups of 3, but I have 1 left over, which means the entire number is not divisible by 3. 160 is not divisible by 3 because 1 plus 6 is 7, which is not divisible by 3. 1 from the hundreds, 1 from each of the tens to give me a total of 7 leftovers. That's 3 equal groups of 2 with 1 left over, so it's not divisible by 3. A number is divisible by 4 if the last 2 digits are divisible by 4. We can ignore the thousands because every 1,000 is 4 equal groups of 250. We can ignore the hundreds because every 100 is 4 equal groups of 25. My 10, I can't break into 4 equal groups with a whole number in each group. So instead, now I have to look at the tens and the ones, combine these, and see if I can make 4 equal groups. In this case, I have 10, 11, 12. 12 is divisible by 4, 4 groups of 3, so this representation would be divisible by 4. Try these examples and check back in. Welcome back. 1,356 is divisible by 4 because 56 is divisible by 4. Ignore the thousands and the hundreds, combine the tens and the ones into 56, and I can get 4 equal groups of 14. So the whole number is divisible by 4. 1,225 is not divisible by 4 because 25 is not divisible by 4. Ignore the thousands and the hundreds. 25 divided by 4 is 6 remainder 1. That is 4 equal groups of 6 with 1 left over, so this number is not divisible by 4. 160 is divisible by 4 because 60 is divisible by 4. Ignore the hundreds. My 6 tens can be broken into 4 equal groups of 15. 60 is divisible by 4, so the entire number is divisible by 4. A number is divisible by 5 if the ones place is 0 or 5. We can ignore the thousands because every thousand is 5 equal groups of 200. We can ignore the hundreds because every hundred is 5 equal groups of 20. We can ignore the tens because every 10 is 5 equal groups of 2. We have to look at the ones. If I have 5 ones, that's 5 equal groups of 1. If I have no ones, I don't worry about them. And if I have any other value in the ones place, I can't make 5 equal groups. So this representation is divisible by 5 because I have 5 ones. Try these and check your answer. Welcome back. The first number is not divisible by 5 because the last digit is not 0 or 5. I ignore the thousands, the hundreds, and the tens. I can see 5 ones and then 1 left over, not divisible by 5. 1,225 is divisible by 5. Ignore everything except the ones. I have 5 ones or 5 equal groups of 1, so the whole number is divisible by 5. 160 is divisible by 5. I don't have any ones. I can ignore the hundreds and the tens, and the ones don't cause a problem, so the whole number is divisible by 5. A number is divisible by 10 if the ones place is 0. I can ignore the thousands. Each thousand is 10 equal groups of 100. Each hundred can be ignored because it's 10 equal groups of 10. Each 10 can be ignored. It's a group of 10 itself, or you can think of it as 10 equal groups of 1. If I have a 1 through a 9 in the tens place, I can't form 10 equal groups, so it's not divisible by 10. The number on the screen is not divisible by 10 because I do not have a 0 in the ones place. Try out these examples and then check back in. Welcome back. Only the last number is divisible by 10 because only the last number has a 0 in the ones place. In the other numbers, I have 6 in the ones place. I can't form 10 equal groups. In the second number, I have 5 in the ones place. I can't form 10 equal groups. In this case, I have nothing in the ones place, and I have 160 as a multiple of 10. For all of these, when I was talking about equal groups, I was talking about whole numbers in my equal groups, not fractions.